Welcome to day 4 of exponential functions. In this lesson, we're going to determine if an exponential function represents growth or decay. And then we're going to find the growth factor of that function. I'm just going to turn my pen on so I don't mess up again. Okay. All right. So in an exponential function, y is your final amount. A is what you start with. It's the starting amount. It is what happens at time t equals 0 or x equals 0. B is your common ratio. You remember we talked about the common ratio is the number that's being multiplied each time. Now, this common ratio has to be positive and it has to be greater than 0, but it cannot equal to 1. Okay? Has to be greater than 0, but it can't equal to 1. So it can't be negative or 1. And that's your common ratio. Now your common ratio could be a fraction, like you could be dividing by 2 each time or dividing by 4 each time. From the common ratio, we're going to find what we call the growth or decay factor. To find the growth or decay factor, we take 1 and we subtract whatever b is. Now this value has to always be positive. So if I subtract that and get a negative number, I just take the positive of it. And then I multiply by 100 to turn it into a percentage. So we've already talked a little bit about what an exponential function looks like. Let's differentiate between a growth and decay. This is a growth function because it's increasing as we go from left to right. So we can see that it's going to keep going on and on and on quickly. This is a decay factor because as we go from left to right, we're going towards 0. Your values are getting smaller and smaller and smaller. Notice that they approach 0, but they will never pass. They will never go negative because 0 is what we call an asymptote here. The same thing here. It's going to get closer and closer to 0, but it's never going to go past 0. So once again, when b is between 0 and 1, it indicates decay. So when b is less than 1 but greater than 0, we have exponential decay. When b is greater than 1, it indicates exponential growth. What if b is equal to 1? B is never equal to 1. And then our growth factor, we talked about that. We take 1 minus b and multiply by 100 to get a percentage. So let's do a few examples. Looking at the graph, can you tell me whether or not this is growth or decay? Okay, so looking at the graph, I can tell that this is exponential growth because it's increasing as we go from left to right. My growth factor, so my function is, I don't know if you can see that, my function is 2 raised to the x. So my b value is 2. That means the function is doubling each time. So my growth factor, remember to find the growth factor. We do 1 minus 2 times 100. So 1 minus 2 is negative 1, but we take the absolute value of that. So we say that this has a growth factor of 100%. The initial amount is a. If there's nothing listed here, it's understood to be written as 1 times a. So my initial amount here is equal to 1. By the way, this a value is also my y-intercept. Okay, let's try another example. Now, again, we can look at this function and determine that it is decay because it is decreasing from left to right. My value of b is 1/2. So my growth factor is 1 minus 1/2 times 100. So 1 minus 1/2 is 0.5. So times 100. So this is my growth factor then is 50%. My value of A, remember, if there's nothing here, it's understood to be 1. So in this case, A is 1. This one is a little bit difficult to see, so we want to know if it's growth or decay. And this is actually decay. But it looks, it's going to be hard to determine our growth factor here because our X value is 0.01. So we can write this as 2.1 to the X power. So 2 raised to the 0.1 value, it's going to be like, I'd have to take a calculator and figure out what that is, but if you take your calculator and do 2 raised to the 0.1, you get 1.07. It doesn't make sense. So let's just not do that because I won't give you any where you have to look at it raised to the 0.1. Yeah, that's right. 2 raised to the 0.1 is 1.07 apparently. Okay. But we can look at this and tell that it's decay. So growth or decay, this is growth because it's increasing from left to right. It's growth. Now, when we're given an expression, we determine if it's growth or decay by the value of B. So in this case, this B is 5/4, which can be written as 1.25. And since B is greater than 1, this is a growth function. So if you were to graph this, you would see that it's growth. Our growth factor is going to be the absolute value of 1 minus 1.25, which gives me negative 0.25, but I take the positive of that. And then remember, it's 0.25 times 100. So it's 25%. So this is growing by 25% each time. The initial amount is simply my number on the outside, so A is equal to 2. That's my initial amount. Okay, growth or decay, because B is equal to 1/5, which is 0.2, and since B is less than 1, this is decay. My decay factor, or my growth factor, is the absolute value of 1 minus 0.2 times 100, which means that it's decaying by 80%. My initial value, A, is simply whatever's on the outside of that parenthesis, so my initial value is 0.6. Growth or decay? Well, B is 1.45, and since it's greater than 1, we say that this is growing. My growth factor is 1 minus 1.45, absolute value of that, times 100. So 1 minus 1.45 is 45, so that's like 45%. So it's growing by 45% each time. My initial value is 3/5. Growth or decay, B is 1.113, and since B is greater than 1, therefore it's a growth. And then my growth factor is the absolute value of 1 minus 1.113 times 100. which is going to be 11.3%. So it's growing by 11.3% each time. My initial value is 2 because that's my initial value. So what do you think, growth or decay? Okay, hopefully you said decay because B is 0.6. And so that means because it is less than 1, that means it's decay. And my decay factor is the absolute value of 1 minus 0.6 times 100, which is 1 minus 0.6 is 0.4, so that's 4%. Is that right? So it's 0.4, or is it 40%? It's 0.4 times 100. It's 40%, sorry. Okay, growth or decay? Okay, hopefully you said decay because B is 0.005 and B is less than 1, so therefore it's decay. And my decay factor is 1, the absolute value of 1 minus 0.005 times 100. I'm just going to use the handy-dandy calculator to calculate that. So it's 1 minus 0.005, and then we're going to multiply that times 100. And so it is decaying by 99.5%. Okay, growth or decay? And the last one I didn't give the A value, but hopefully you can figure that out. Growth or decay? So this one would be growth because B is 1.075, and that makes our growth, and B is greater than 1. So that makes our growth factor the absolute value of 1 minus 0.075 times 100. And I think moving that over 2 places, that gives us 77.5% growth. My initial value is 1/3. Okay, so here's a recap of what we've done. If B is greater than 1, then the function is growing. If B is between 1 and 0, between 0 and 1, then the function is decaying. To find the growth factor, subtract 1 from B and multiply by 100. Remember, the growth factor is always positive, and the initial value is simply A. That is the value at x equals 0. So this was a short video, and you have a short assessment online. It's like 8 problems. So please go online and do those simple A questions, and I will see you Monday. I will not see you Monday, but have a good weekend.